All right, welcome to 5 point. Oh, it's be 5.4, not 5.3. My mistake. It's 5.4 though. It's sum and difference identities. All right. We're mostly going to be using these three formulas throughout. They look slightly complicated, but we add to two different degrees or radians, and add or subtract two different degrees or radians. Hence the name sum or difference formulas, and then apply your formula using this. The A and B value are going to be values that are on your unit circle. Okay. The purpose of this, which we're going to write down below here. Let's just do this. What's the purpose of this in trig? To solve trig values that aren't on your unit circle. Okay, so that's the main purpose of this. Okay, we want to be able to solve values that aren't unit circle. Now, can we do any one? Like, can we just pick up and do cosine of 51 degrees? No, that's not what this is for. The ones I'll be giving you, though, you'll be able to add or subtract two numbers that will get you the value you're trying to find. Okay. Now, one thing to note, I would recommend pausing this right now before I mess with these a little bit. But pause it, write them down. I'm gonna emphasize something. All right, here's what I'm emphasizing. Look at what I did right here and right here. Okay, so with sine, when you're adding, you'll be adding these two together. When you're subtracting these two together. Now over here, with cosine, when you're adding, you're going to be subtracting in the middle. And when you're subtracting, you'll be adding in the middle. Hence, the reason I wrote the formula like this. And with tangent, same thing here. When you're adding, you're subtracting on the denominator, but adding the numerator. When you're subtracting two values, you're subtracting the numerator, adding the denominator. All right, so I wrote out an expression, and we want to write it as one sine or cosine function, okay? So which of the three formulas do you recognize this as? Yes, you should recognize this as cosine, because you see cosine, cosine to start. Now keep in mind, since you see addition in the middle, you're actually subtracting. So we'll be subtracting the 7 pi over 8 and minus the 5 pi over 24. Common, times by 3, 21, 16 pi over 24. Reduce that. Now, how do I get 16 pi over 24? Get a common denominator, folks. Come on. Multiply the top and bottom by 3. 21 minus 15 is 16. Reduce. 2 pi over 3. So we're going to use sum or difference identity to find the exact value. Now, first one, cosine of 15 degrees. What two values can you subtract to get 15 degrees, or add? In this case, you can't add, right? Unless you want to do some negative numbers, which is silly of you. So what two numbers? 45 and 30. Because 45 minus 30 is 15. Now, you could have rattled off a bunch of others, right? I want to keep it simple. Don't overthink. 45 minus 30. So, formula time. So, we got cosine 45 times cosine 30. You're adding in the middle. Sine 45, sine 30. Cosine 45 is root 2 over 2. Cosine 30 is root 3 over 2 plus root 2 over 2 times 1/2. So it's going to get us root 6 over 4 plus root 2 over 4. And don't be a silly goose. Combine and make it root 6 plus root 2 over 4. Now this one, you're going to be able to add or subtract. I'm going to pick adding. So as you can see in your unit circle, there's nothing over 12. So we're going to need to get common denominator. So I'm thinking pi over 6 is actually 2 pi over 12. I'm thinking pi over 4 is actually 3 pi over 12. And pi over 3 is actually 4 pi over 12. Can any of these add up to 5 pi over 12? Yes, the first two I listed. I just did the 4 one for fun because, you know, math's fun and all. So, atom sine of 2. I'm going to keep it simple here and just go back to writing pi over 6. You know where my pi over 6 came from, though, right? Yeah. Pi over 6 plus pi over 4. Formula time. That's going to get a sine of pi over 6 times cosine of pi over 4 plus sine pi over 4 times cosine pi over 6. Sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2 plus sine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2, giving us the same answer as before. Root 2 over root 2 plus root 6 over 4. All right, verify each cofunction identity using sum or difference identity. So use sum difference formula. This should equal out to the sine theta. We simplify, so cos. Using our difference formula for cosine pi over 2 cosine theta plus sine pi over 2 times sine theta. Cosine pi over 2 is 0, and 0 times anything is 0. And sine of pi over 2 is 1. Which is 0 times anything is itself, so we're just going to end up with sine equals sine. Next, sine. We got sine pi over 2 times cosine x plus cosine pi over 2 times sine x. Now sine pi over 2 is 1. Similar situation here. Cosine pi over 2 is 0, and 0 times anything is 0. So we're left with cosine x. There you have it. I appreciate you. I appreciate watching. Don't forget to like and subscribe. Haha. Bye.